Good morning. I am Andreas Schwarztrauber, Market Development Engineer for Microchip at Arrow in Central Europe. And I would like to welcome you to our webinar, AI at the Edge, Implementing Convolutional Neural Networks in Low-Power FPGAs. This event started as a local event planned for Frankfurt, Germany, and then Corona hit the world. We decided to virtualize it by Teams meeting, but then the amount of registrations jumped up and we decided to switch to live event. So this is actually the first time we are using this tool across companies. So I hope it will work out. So the only way for you to interact with us, the presenters, would be through the Q&A function to ask questions, and we have FAEs attending that will hopefully be able to answer your questions. In case a question remains unanswered, please do get in touch by email after the event and we will follow up as soon as we can. So next slide, please. So the goal of this seminar is to demonstrate how to implement convolutional neural networks in low power FPGAs for edge type of applications. So at the edge, you're probably limited in PCB real estate. You won't be able to use stuff like heat sinks or thermal fans. So low power and small packages is probably what you're looking for, which is why we believe flash FPGAs are an interesting option to consider. Next slide, please. So we have several partners contributing to this workshop and seminar. We have Doulos, a very well-known training company, developing and delivering know-how to the industry. We have ASIC Design Services, a South African-based company delivering their IPs and services worldwide and also to the local South African market. We have Microchip, a $6 billion semiconductor company and #1 flash FPGA company. So you probably have heard that Microchip has recently acquired Microsemi, and Microsemi themselves had acquired Actel some time ago. So this is how FPGAs came to the Microchip portfolio. So in this whole consolidation phase that is going on in the industry right now, Microchip is probably going to be one of the survivors. And we have Arrow, a global distributor, now transforming itself to a technology platform provider. So what does that mean? Components are still our bread and butter, of course, they always will be, but services around those components will become more and more important in the future, and we will offer more and more services and service platforms where we connect our end customers to our design partners like Doulos or ASIC Design Services. Next slide, please. So we have a pretty interesting agenda, I hope. Doulos will be giving us a little bit of background regarding artificial intelligence. We call that AI in a nutshell. We'll have a short break after that where we show a video. Then ASIC Design Services is going to present on their core deep learning development framework and show some demos. We'll have another short break plus video after that. We'll also use the breaks to get to the Q&A section and answer questions. And then we have the hands-on part of the presentation. Basically, this will require a little bit of software and hardware, but if you don't have that ready, don't worry too much about it. You can just basically follow the hands-on section as we go and then probably reproduce what we are doing on your own later on. And then we'll have more time for questions and answers. Next slide, please. In case you do want to follow the hands-on workshop, this is what you would need today. A laptop with a camera, an SMF2000 board from Trans Electronics. It contains a little Smart Fusion 2 SoC device, and you need the Libero SoC development software along with a Silver license or whatever license you have, plus soft console. Next slide, please. So as I mentioned earlier, we'll be using flash FPGAs in that workshop. Microchip is the #1 flash FPGA provider, either flash or Sonos. Sonos stands for silicon oxide, nitride oxide silicon, which is very similar from its properties to flash. So it's non-volatile. So one device is all you need, requiring less PCB real estate. These FPGAs are true flash. That means they are SEU immune. And also we have very low static power, and also overall power is quite low compared to SRAM. So SRAM, of course, is volatile. So you always need a configuration device. This configuration device could be either off chip, so you have a 2-chip solution, or you have it on the same die or within the same package, but you always need some sort of configuration and boot process. SRAM is always susceptible to SEU errors, and it has relatively high static power consumption. Next slide, please. So I'm not saying that flash is superior to SRAM. Of course, all the major FPGA vendors do SRAM FPGAs, so they have their justification, but flash has certain properties, and you need to know about these properties to choose the right technology for your application. And we believe that for edge type of applications, flash is a good option. So true flash means anything that can be configured in an FPGA is based on flash cells, whether it's combinatorial logic, whether it's flip-flops, IOs, routing, just anything that can be configured is done in flash cells. And Microchip is the only FPGA vendor doing that. As I mentioned, that means we have a relatively low static power consumption. So if you have low system frequencies, the static power consumption portion would be the main one. So then you have a huge benefit over SRAM. So the higher the system frequency, the less the advantage. So let's say for typical designs around 100 megahertz system frequency, we should be roughly 50% better overall power consumption than SRAM-based technologies. But that's just a rule of thumb, let's say. Of course, it also depends on the temperature. So for the static power consumption, if you have high ambient temperatures, for flash, the power consumption will increase linearly, whereas for SRAM, it's more an exponential growth for high temperatures. So in summary, for low frequencies and high temperatures, that's where you have the most benefit for flash FPGAs. And there are tools basically to estimate how big your benefit might be. Of course, flash is live at power up. It's just in the nature of flash. We have 2 different flavors of FPGAs, flash FPGAs. We have the so-called design security FPGAs. They come with no cost adder. That means your IP is very well protected, even against so-called side channel attacks like differential power analysis. And we have the data security FPGAs. That means the data at rest or in transfer is also protected through cryptographic algorithms, or can be protected. So these are the data security FPGAs, and they come with a little cost adder. As I mentioned earlier, flash FPGAs are SEU immune, so they are especially for applications in the aviation field or safety critical applications. You can be sure that you have no configuration bit errors through radiation. And one chip is all you need, since you don't need a configuration device. So those are the properties of flash FPGAs. And just keep that in mind when choosing your FPGA technology. Next slide, please. So this is just a brief overview of the portfolio of flash FPGAs at Microchip. From the very left to right, we have small CPLD-like FPGAs starting at 100 LUTs. In the middle, we have the SmartFusion 2 that we will be using today during the hands-on session. And at the right, we have mid-range FPGAs like PolarFire, up to 500 KLUTs. That's probably what you will be using for your neural networks. But the solution scales from ECLU2 type of devices to PolarFire type of devices. And there's always an SoC version of the FPGA as well. So we have pure FPGAs like ProASIC3, ECLU, ECLU2, PolarFire, and we have SoC FPGAs like SmartFusion, SmartFusion 2 that contain a Cortex M3 MCU, and PolarFire SoC that contains also a 5-core RISC-V 64-bit processor. So that's quite powerful. Next slide, please. And all this comes in relatively small packages, starting at 11 by 11 millimeters for 100 KLUT FPGAs. 300 KLUTs requires a little bit more space with 16 by 16 millimeters, but the solutions can be quite compact. Next slide, please. So in case you do want to evaluate PolarFire, this is a nice evaluation board I can recommend. It's the Everest development board with an MPF 300 KLUT device. It contains memory and also extension possibilities through FMC daughter cards or PMOD, many interfaces, and it comes with a Libero SoC Gold license. So that's just a brief overview about the technologies we'll be using today. And next we'll be presenting John Ansley from Doulos and give you a little bit more background about artificial intelligence. Thank you very much and enjoy the rest of the seminar.